Error analysis. There are two types of error. One is systematic error, the other one is random error. Systematic error. Those errors which occur in a definite pattern are known as systematic error. The cause of these errors are known precisely and can be minimized. Under systematic error, we have three more types of error. One is instrumental error. These errors are caused due to faulty instrument. It may be due to the imperfect design or calibration of the measuring instrument. Second, personal error. These errors are caused due to carelessness or inexperience of the observer. Parallax error is one of the example of personal error. Imperfection in experimental techniques. These errors are caused due to the change in temperature, humidity, pressure, etc. during the experiment, which may affect or cause changes in the experiment. Now, to talk or to tell you about the actual value and the measured value, let me take an example. So let us consider that there is a football field and we ask the contractor who has built the football field that what is the length of the field that he has built. So he tells that it is 320 meters. Let us assume that he tells the length of the football field is 320 meters. Since he has built the field, we can assume that this is the actual value or actual length of your football field. So the actual value I can tell, or actual value can also be told as real value, or it is also known as real value. So what is the actual value, true value or real value of length? It is 320 meters. Now, let us assume that now I want to measure the length using a tape. Okay, I have a spiral tape and I want to measure the length. Now, if I measure that to be 300 meters, let us assume when I measure, I get it to be 300 meters. That 300 meters will be known as measured value or approximate value of length. So I can write this as 300 meters. Basically, if I'm measuring something, that will be the measured value. If we know the actual value or the real value, that will be 320 meters. I hope the example is clear. Moving on, we can define absolute, relative, and percentage error using true and measured value. Absolute error. Absolute error is the magnitude of difference between a measured compared to a true value, meaning that the absolute error will be the modulus of true value minus the measured value. And you have to note that always your absolute error will be a positive quantity. Relative error. Relative error is the ratio of absolute error to the true value. Relative error shows the size of the error relative to the true value. Basically, it puts the size of error into perspective. Third one, percentage error. Percentage error is simply relative error multiplied by 100. The percentage error shows what percentage the error is of true or accepted value. Now, let me take few questions, or before that let me just show you the formulas of absolute, relative, and percentage error. So absolute error is given by xt minus xm, where xt is the real value and xm is the measured value. Of course, we have a modulus sign here because absolute error always it should be a positive quantity, right? We have seen that in this slide. Next, relative error. Relative error is absolute error over actual value. So it can be written as xt minus xm divided by xt, where xt is the true value, xm is the measured value. Percentage error. Percentage error can be written as xt minus xm divided by xt multiplied by 100, where xt is the real value and xm is the measured value. Let us go to question number 1. Find absolute and relative errors. The actual value is 125.68 millimeters and measured value is 119.66 millimeters. So let us start with the solution. Let us write what is given in the question. So it is given that the actual value, which also can be told as your true value or your real value, that is given to be 125.68 millimeters, and the measured value is given to be, so the measured value is given to be 119.66 millimeters. Now, what do we have to calculate? We have to calculate absolute and relative errors. Now, let us go back to the formula. What is absolute error? Absolute error is true value minus the measured value, right? In terms of a formula, it is xt minus xm, where xt is the true value, xm is the measured value. So this is going to be xt, this is going to be xm, right? So what is going to be your absolute error? Xt minus xm under modulus. So I can write here xt minus xm modulus. This is going to be your absolute error. So what is your xt? Xt is 125.68 minus xm is going to be 119.66. So I will be getting the answer as 6.02 modulus, which is going to be 6.02, which is plus itself. So the modulus is will not make any difference. 6.02 m. This is going to be the absolute error. Now, what is your relative error given by? We know that relative error, it is given by absolute error divided by the actual value. So I can tell xt minus xm divided by xt. So xt minus xm divided by xt. This is the formula for relative error. So xt is 125.68 minus 119.66 divided by xt. What is your xt? It is 125.68. So when you calculate, you will be getting the answer as 0. Mm, I guess it is 0.0478 millimeters. So this is going to be your relative error. Question number 2. The radius of circular plate is measured as 12.65 centimeter instead of actual length of 12.5 centimeters. Find the following in the measuring the radius. First is absolute error, second is relative error, the third one is percentage error. Let us write what is given in the question. It is given that actual length, so it is given that the actual length, which is also your true length or your true value, right? True length, or you can tell your true value, right? What is that? That is given by 12.5 centimeters. This is going to be your x. Now, what is your measured value? Measured value here, what is the value you are measuring? The value you are measuring is length, or basically your radius. Radius is nothing but your length, so that I can tell as 12.65 centimeters, which is going to be your xm. So you know what is your xt, you know what is your xm, right? Now, what is your absolute error? Absolute error is given by xt minus xm in modulus, right? So what is going to be the answer here? Can you guess what is the answer? Yes. So 12.5 minus 12.65 under the modulus. So modulus of, we will be getting here minus 0.15. So 0.15 centimeters. This is going to be your absolute error. Next, your relative error. What will be your relative error? Now, your relative error is given by xt minus xm divided by xt. So the answer is going to be 12.5 minus 12.65 under the modulus. Here also the modulus sign divided by xt. So this is going to be 0.15 whole divided by 12.5. So after solving, the answer we will be getting is 0.012 centimeters. Next, we have to calculate what is the percentage error, right? So the percentage error, it is given by xt minus xm divided by xt multiplied by 100. So basically what I have to do, I can just multiply your relative error, that is 0.012 multiplied by 100. So the answer is going to be equal to 1.2 percentage. So I have got my absolute error, I have got my relative error, I have got my percentage error. Moving on to question number 3. The accepted distance between Earth and Moon is 2,38,855 miles. Akhil measures the distance as 2,49,200 miles. What is the percentage error? Option A 4.3%, option B 6.3%, option C 8.3%, option D 10.3%. Fine. So let us write what is given in the question. So what is given? It is given that accepted distance between Earth and Moon is. So accepted distance can be taken as xt or your true value. So that is 2,38,855 miles. Right. So let me write miles also. Fine. So xt is given. Akhil measured the distance. So xm is also given. So that is 249 200 miles. What do we have to calculate? We have to calculate our percentage error. So the percentage error is given by. So the percentage error is given by xt minus xm divided by xt multiplied by 100. So this is the formula for percentage error. So I can write this as 238,855 minus 249,200 whole divided by, again, 238,855 multiplied by. So I will be getting your percentage error as 4. So this I will be getting 10345 whole divided by 23855. Sorry, I think I added one. Yes, 23885 multiplied by 100. So upon solving, you will be getting this 0. So 0.0433 multiplied by 100. So the final answer is 4.33 percentage. So option A is going to be your correct answer.